Yeah, it's coming. I promise. So I'll try to work on it over the weekend. All right, guys. We're gonna get started. So this is week 6. The lab today is finishing up what we started last Thursday. Remember, I didn't assign that one last Thursday, and we didn't finish it either. But I will assign it today. That's an extension of the CBC one. Right? So, but this one has the Feistel network in it. If you remember, I believe we had done the encoder part or the uh, encryption part, and then we're going to do the decryption today. And that's essentially the goal. We'll finish up. Today's the last of this sequence of symmetric encryption. And then on Tuesday, we will start asymmetric encryption, which is going to be key sharing and algorithms like RSA, etc. So we're switching gears a little bit to more like algebra-like things, but actually very interesting. RSA is like there's even books that you can read, just like almost like not novels, but that kind of popular book just about history and math because it's such an interesting topic. So, and I'll recommend a few. All right. So yeah, so let's take a look here. So I'm recording. I need the virtual machine. So I'll do a quick review of what we did on Tuesday, just so that we get caught up. And then you'll be doing the same thing as usual. Make sure the algorithm works, that you can encrypt something, and then you're going to work with your partner and encrypt something, this time using the Feistel network. Okay. And then the CBC, I believe that was due today or a week ago. Okay, yeah. So good. We need the virtual machine. Right, so we're going to log in. Okay, so let's open up the terminal. L, CD, desktop. We're going to navigate into our folder. So it's fall 2025. Right, and I think we're in the XOR first folder. So there's a few scripts. I just changed the name here. They seem to be about the same size. When I loaded this to GitHub, so you can of course get this from the GitHub if you want to download what we did in class that day. Um, and I will pick up from there. All right, so yeah, so let's just get started. Let's do nano des XOR 2 .py. So we're gonna work on it. I'm gonna just go over this as a review. And then remember, so this is your homework. So You just have to make sure that it works logically. All right, so let's get to the main section, I suppose. So we have this message. This is a top secret message, and then numbers and the alphabet. All right, we printed. We've defined the length to be blocks of 8. Okay. We print that length, and then we had created a function called create blocks. So this takes a plain text and the length, and it's just going to create a list of blocks, right? So that's essentially this one here. That should work just fine. So I printed. Then, because we are using Feistel in a CBC type of mode of operation, with the Feistel being, that part of the data encryption standard, I'm generating a key and I'm generating the IV using the same function. Remember, these are byte arrays. Essentially, with this code, the algorithm, one of the hardest parts is just dealing with the byte arrays. Sometimes that format changes, etc. All right, we print them, and then we provide the list of blocks, the key and the initialization vector, plus the length of the block to cipher a list, to encrypt message. And then that function is where we're going to go in and kind of dive into it. But when it's done, it produces cipher list. And here I'm just printing it. So remember, because you're going to work with a partner, you're going to have to convert this, not convert it, but just use Pickle, the Pickle library, which is going to help you to just dump it into a file, some kind of a text file. You'll send that to your partner. Then they're going to grab that file, load it into their script, and decrypt it, essentially. And I believe using Pickle is the best way of solving these issues. I mean, there are other approaches, obviously. You do not want to copy paste this in an email or something, because those strange characters are going to become corrupted. Okay, so that's a terrible idea. So, just save it to Pickle is the easiest. Certainly, you can write your own functions if you want. All right, so that's essentially it. So let's just make sure that it runs first before we actually, and again, if you guys have any questions, let me know. But let's just make sure it's running first, and then we'll dive into that encryption part. So Python 3, right, and you can see it prints done. So we have the list of byte arrays. So this part I'm not going to do, right? Saving it with Pickle, I leave that to you guys to solve. But now what I need to do is I need to take this list of byte arrays. This is the cipher, and I need to decrypt it, right? So I need to follow the logic of the Feistel network and CBC as well. So both approaches. Okay, so let's go ahead and take a look. So we have to dive in. To the function encrypt message, which is this one. So now we need to go here. We have encrypt message, and it's very modularized. So there's several functions that call other functions just to keep it simple. But we take the block list, the key, the initialization vector, the length of blocks. We create a list of ciphers, and then we just iterate for the length of the block list, right? All the elements in there. And then we just index by index, we can grab them. So we can grab the first block, which is going to be 8 bits, and the initialization vector, which is also 8 bits. And so we send it to cipher 1. If you remember, you could have changed this order, like you've done the key first or something like that. You can play with that idea. All right, this is just how I've chosen to do it, and I think it's secure enough for this demo. So we have the block list IV that goes into encrypt 1. That'll produce a byte array of 8, which makes things simple. And then that's going to go cipher 1 will go into encrypt 2, where you just encrypt it with a key. And then that should produce cipher 2, which is also a byte array of 8. Okay, so now that gets added into the list, and that's it. And remember, the IV just needs to be replaced because we only use the IV in the very first encryption of the text, and then in subsequent encryptions or of blocks, we're going to use the previous generated cipher. So that's why cipher 2 here is assigned to the initialization vector. And this is actually just CBC. This was that homework. All right, so then we have to drill down into these two functions. So cipher 2, I believe, is, or encrypt 2, I should say, is pretty simple. And it's the type of function we've been using throughout kind of our approach. We have a block and a key, and then we just create a list comprehension. You can see that all the way here. And then inside, we just iterate. So for I in range, length of the block. So each block. And then notice we just XOR one element at a time. So we take the key of size 8, and we take the temp cipher block also by index and XOR both of those with the caret symbol, which we have established as our XOR operation. So this is pretty simple. The complexity comes in, and this is where the key gets XORed. The complexity comes in cipher 2, sorry, in encrypt 1, this one here. And it's especially challenging because we're going to have to do this in reverse, right? So, and so we have to figure that one out a little bit. All right, so let's go out to encrypt 1. And that's this function over here. And encrypt 1 makes use of two other functions, right, in the process. So here we have encrypt 1, but essentially what is helpful is we always know that there's a block of 8. That's essentially like your anchor, right? Whenever you get lost, you arrive at that block of 8. So that's going to be plain block, which is just a text, and the initialization vector in its case, IV, the first element, because we're going forward. So now we take those two elements and we go to encrypt that function, which is, I think, one of the original functions. You can see it there. Block of 8, key of 8, and we do the same thing. A list comprehension, okay? And in the list comprehension, we have a for loop for I in range, length of the plain message, and we just XOR with the key here, which in this case, although I'm using the term key, if you pay attention, it's actually the IV. Do you guys see that? So it could be the key though. It's just, it doesn't really matter. All right. So that, you guys know you have flexibility, and it starts to give you insights into, okay, this could be ECB, this could be CBC, this could be OFB, just by changing some of these things. All right, but we're just going to focus on this. All right, so then this one just does the same thing. The initialization vector, or whatever is provided there, is XORed. It's XORed with the letter. But remember that this letter has to be converted from string, that ASCII character, into an integer. And at that point, we can process it. Okay. All right, great. So that's easy enough. Now we take a look at, we have a temp block over here, and now it's going to go, you can see I've written here DES. So this is where it goes into the data encryption standard algorithm, which I've made some simplifications. If you remember, one of the things I did is I removed the S box, right? I'm not doing that. I'm also not like extending the size of the block. All right, we're just keeping it more simple. We're just going to do 3 rounds, although you could just change this to 16 and it would probably work, right? But just keeping it at 3 rounds. All right. So now if you remember that algorithm, right, the key of it was that we had to take the block and split it into 2 blocks. Remember, 2 halves, and then one slides down, and then the other one, this block comes in, goes into the function, produces another one, they get XORed, and that becomes the next one, right? So you have to kind of picture that in your head. So in this case, I've taken temp block and just divided it into 4. I believe we printed this all already the last time, so we checked that the size is matched and everything, so it should be good. All right, once that's done, it goes into the Feistel network, where we're going to implement the logic. So essentially, I'm reassigning the names LR and R here to sorry, L and R here to L0 and R0, and then we perform the basic operations. So we're going to generate R new and L new by switching them inside this. The Feistel network is actually where the tricky thing is, okay? And if there's any problems with our code, it's going to be here, right, in this logic. Once we get R new and L new, we just change it to L and R and then concatenate that byte array again, and we have a block of 8. So now we dive in to the last part, the Feistel round. All right. So this is the tricky part, but what's nice about this code is that we know certain parts of it are correct. Like here, it's simpler, right? And we can just focus then on a few things going on in the Feistel network, which is what I've left a little bit fuzzy, right? So that you guys can think about it a little bit. All right, but it should be reversible. So I have the Feistel network function here. I just provide L0 and R0, and we're sending the initialization vector in there as well. So which would have been the key, by the way, right? So if you remember, I made that note. So if you feel like changing it, go ahead. You don't have to, though. But to be truly correct in the algorithm, we would have used the key here in the Feistel network, if you remember, in the F functions. Any questions about that? All right, great. So, but here I'm just using the IV. So let's dive into the Feistel network function, which is should be the last one here. So you can see that there. So I made a note that the 2 blocks that come in are 4 bytes or 4 bits, but the IV is 8, right? So to simplify this, what I've done is I'm just using half of the initialization vector. And we could have expanded, but that would have been additional code. I'm trying to keep this very minimal. All right, and then so here we take so this would represent going into the F function, right? Yeah, F out, right? So it was named F out, so it implies that this is what comes out of the F function. And the F function here is just taking, in this case, the IV and XORing it with R0, right? So those 2 blocks, that becomes F out. So if you look at encrypt 2, maybe it's both. Encrypt 2 is the same thing we've used before, just reusing it. Take 2 byte arrays of some kind and XOR them together via list comprehension. This is going to work even though they're of size 4. All right, and then once I have F out, then we just XOR it with L0, the other one, and that essentially the same operation, encrypt 2 to produce L, and then after that it's just about sending them back flipped. Does this make sense, guys? So this is the key, right? So just look at the diagram, make sure that this is correct and that you understand it. So now we're done with reviewing the code, and we're going to go ahead and do the decryption part. All right, so let's start adding that in. And the bit of a challenge here is, remember, it's in reverse. All right, so but take a look if you're implementing it. Probably the best thing to do would be to first take a look at sort of encrypt message, right? That gives you an idea of how this function would work. And then given that, we can begin. And also, actually, let me write it in the main now, because this is going to drive the whole thing. So I printed the cipher list, right? And now I have to do decryption. We're going to decrypt. Whoops. Decrypt. All right. So we're going to call it decrypt message, or decrypt, in this case, decrypt cipher. So I'm going to create here pickle after pickle, just to remind you that you have to do that. Decrypted, encrypted blank, let's say. Okay. So we're going to use a function, decrypt cipher. Okay. And we're going to think about what this should use. So we need the cipher list, obviously. Cipher list. All right, we're going to iterate through this. Have to think about, we have block, 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 block. That's encrypted. And we went in that direction. Now maybe we have to go in reverse, right? So we have to think about that. So cipher list. We're going to use the key. So same key. This would have been shared already between Bob and Alice. And they also know the initialization vector, right? So they need to have that information. All right. So that's what goes into the decryption. Once that's decrypted, we can print this block after pickle decrypted line. All right, so we want to print that list. We can also try to join them. So this might be so that it's a little bit more presentable. We can do print. And then this is just pure Python syntax. So that's two single quotes dot join. So this just joins things with nothing. Like if I said dot dot dot, then it would join things separated by three dots. So in this case, if I could choose a space, or in this case, I'm choosing none. All right, so you can play with it. This should say join. Yeah, and then that's going to be for the separate blocks. But now I'm going to create here a list comprehension, and I'm just going to iterate through the four block. Oops. Four block in the list. So the list is called after pickle decrypted blank. All right, so we iterate through this, and then each block also just gets joined. I'm going to do single quote dot join, and then this is just going to be, all right, so this should just give you a nice, it's not related to the cryptography at all. This is just so that you can get a nice printout of the message if we've done a good job. All right, so we have this process. Now we need to start defining the function decrypt cipher. Okay. So we're going to go over here to the top. And we have a space right here. So I'm going to do define decrypt cipher. All right, this takes in the list cipher takes in the key, takes in the IV. And this is colon 1, 2, 3, 4. All right. So now we're going to need a new list of the decrypted blocks, right, that are going to come out from the process as we were trying to reverse it. So that's essentially the idea. All right. So let's see. So decrypt cipher, list cipher key, list of list of decrypted blocks. Blocks. All right, that's initialized 1, 2, 3, 4. The list of decrypted blocks. And now we iterate, right? So that's fair to say we would iterate. So for I in range. Okay, and here we're going to say len of list cipher. 2, 4. All right, now we have to think about how we iterate through this. Kind of just do a, so let's just do this. Let's just, okay, so there's going to be something in from the list, right? So we're going to say temp equal decrypt 1. Okay, we're following the same approach as before. This takes list cipher. Here, I'm just going to leave a question mark as to how we're going to process that. Okay. But it's one of the blocks, or obviously it's in the sequence somehow. All right. So we need to figure that out. So we have decrypt temp, decrypt 1. And then here, it should be either the key or the IV, right? You just kind of have to think about that. So how did we do it in the first one? So we would go block an IV to produce another block, and then that went into the Feistel network, and then what came out just got XORed with the key. Just trying to think about this. Block, IV, Feistel, block, key. So now if I have a block, I would need to reverse that, and then it gets appended to the list, right? So I need that cipher key to produce the temp, correct? That's cipher key to produce the temp. Do you guys agree? You have to look at this one in reverse, right? So that's the key idea. All right, so I'm just gonna plug in here then key. It's yeah, block key. Okay, and that produces temp. So let's think whichever one, there's a trick here that we can play with, but of how it gets done. But let's just think of the logic as if we were going in reverse. So we have key, we have the cipher, and that produces temp. Yeah, I believe that's correct. All right, next one. So now we have temp, and we want that plane, correct? That plane block. This is going to be decrypt to, okay, decrypt to. Decrypt to, of course, takes temp, comma, and it takes so now let's go to the whiteboard actually. It might help more. This is the fun part of figuring this out. All right, so in encrypt forward, encrypt message, we have blocks. Take a block and the IV that was encrypt one. Again, the IV. And that was the plane, by the way. And they get XORed. That produces cipher 1. Okay. But there's a temporary in there, so this is like block. Block. Yeah. And then there might be some issues with the encoding there. Then after that, we go into the Feistel, and this is going to be the tricky part. Feistel. And then what comes out of there, right? If you guys look, encrypt 1, you get L and R again. So that was cipher 1. Cipher 1. And then cipher 1 gets the key. Cipher 1 gets the key, and that goes into encrypt 2. Yeah, and they just get XORed. And then that produced cipher 2, cipher 2. And that gets added to the list, right? That gets added to the list. So now we just have to reverse this. So we would start with cipher 2. and XOR that with the key. Do you guys agree with that part?
Mhm.
Yeah, and then that would give us this cipher 1 that we're seeing here, right? And that's cipher 1. So at least, and then this needs to go into the Feistel, but in reverse. You see that? So that's the challenge. All right, so I think that we had our code correct here. So cipher 2 and key is what we XOR to produce cipher 1 here. Well, let's see. I'm gonna share the screen. Okay, so we have in decrypt, iterate through the list. We need to specify, so obviously it's the last one, right? And so far we've only done the key. They're both XORed. So we'll need to define decrypt 1 as that. Then this one temp now needs to go into decrypt 2, and it needs to use the Feistel network. So here I consistently use the IV in the Feistel network. So decrypt 2 then needs to incorporate the Feistel network to produce the plane. Okay, so let's define decrypt 1 then. We haven't done so already. Decrypt 1 should just be very similar to one of these, right? Oops. Let's do define decrypt 1. It takes a block of 8. Yeah, a block of 8 and the key. It's pretty much the same function here. Let's call it temp cipher gets XORed with, let's call it IV, I guess. Right? And then this is going to be like that. And then we just 1, 2, 3, 4 return byte array, open parentheses, close parentheses. We add the list comprehension in here, and we're just going to iterate. So I'm going to say for I in range len of temp cipher. Do you guys see that? So that's essentially the same thing. And then we just XOR these. It's going to be temp cipher I XOR caret IV in this case. IV also with an index. Basis. So that should take care of that part. Okay, so we have that process. So let's make sure that code is correct. I'm going to comment out, oh, and then we have to figure out the index. So it'll be either an approach where we start from the last and work our way back, or there's another way that we can do it. But let's take, so this would be for I in range. There's several ways of doing this. I guess I'll go with the simplest. What is it? The length of it is, I'm going to say index equal len of list cipher So that should be 8. Or sorry, this is the list, so this should be whatever number it is, right? So it could be um 5. So then it's 25 minus whatever the index is, I. So what does that give us? 25 minus, it gives us the last one, right? And I can increment them. I can go from, I can do for I in range, but go from 25 to 24 to 23 to 22 and so on. Do you guys see that? So let's actually test that out so that we don't have some kind of an offset error. I'm going to do print index. I'm just following the logic as we've discussed it in class. So I'm going to comment out these two with a good error out. All right, so decrypt cipher. Let's put a, yeah, it should work. Yeah. So 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Yeah. So that means we can't, there's 11 blocks in there. So now let's go back to the code. And the thing that we would want to do now is just make sure we are grabbing that block. Yeah, here. You don't need to print the index anymore. I'm just going to plug that in here. Just want to make sure that this is an actual block and there is no offset error. I'm going to print temp. Okay. Control X, Y. Yeah, so there's this. Okay, index out of range. So that means there is an offset. It starts at 0. So then I've got to do like a -1 somewhere. All right. Okay, so here, right? So what do you guys suggest? Just like +1 or -1? -1. All right, so -1. All right, let's try it again. And I'm gonna put an input here just to make sure I know where it's breaking. Okay, Control X, Y, clear. Yeah, so it's working now. Do you guys see that? So we got that far, right? So now we just have to do the Feistel part. And there is the issue where I cut that that IV in half, but I don't think it's going to affect anything. Otherwise, I'd have to fix that part of the code. But I think it works because if I was cutting the other thing, it would be a problem. But it's only affecting the blocks, so it should be fine. All right, so this works perfectly. Great. Hopefully, I'm doing all of it correctly. So now we move to the hardest part. So I'm going to go in here. Got my temp. Here. All right, so I'm going to remove these two statements. Now this function decrypt2 needs to come into existence. So I'm going to say here decrypt2. I'm actually going to put this near where the other one was for the Feistel net, because this is similar. See this. Okay, so define decrypt2, and this takes temp. And what does it take now? It's going to take, I think, so this one takes the IV. This parameter. The IV, right? K, 1, 2, 3, 4. So here comes temp. It's gonna be two, a block of 8 needs to be split into two blocks of 4. Grab the first 4 of that IV, so that's easy enough. And then we just have to think of our logic, right? So here I have, so it's something like this. So I have to take that one, that's 2, and I have to reverse this Feistel network, right? Then I have to do the 4 rounds also in reverse. So that's a bit of a challenge there. Um, and then I have to just put it back together. And then there is this, and then I have to encrypt it with the IV one last time to produce the plane. That's essentially it. Okay. So, so we have to look. So there's a Feistel round in there that uses the IV. Really, what makes sense is to look at this here. Well, there are 2 encryptions here. IV. What does encrypt2 do? Encrypt2. Encrypt2 is just okay. Yeah. So okay, so Feistel round. That's where you cut it. So we need. Yeah, this is like that quiz, right? It's exactly that quiz. So back to the whiteboard, this might help us. All right. So now we're here. We've got the block in reverse. So we have the blocks like this. This came in like that. This came in like this. This XORed with that to become that, right? So now we are coming from this direction and we've got these 2 blocks, right? So we got to split the blocks that's coming in. This one just becomes that one, right? So the opposites. If it's L, it becomes R. And then this one needs to take this one XOR with the key and this to produce that. Do you guys see that? And then we'd have to repeat that 3 times. Got it? So actually not that hard, right? So let's try to remember. We take these 2, split them in half, right? And then so R and L. And then this one just becomes, so L just becomes R, essentially. So L just becomes R. So we've got R and L. R. So L comes in, becomes R. Then we have to do something for L is going to be what? to be key XOR L, which we have, right? XOR the R that comes in. Okay? So it should be like that. So R1 becomes 0. L1 is L0 XOR key XOR R0 to produce L1. Okay. All right. Let's go back to the function. We should be able to write it now. So decrypt cipher, decrypt 2, right? Decrypt 2. Okay. We are. Decrypt 2. 1, 2, 3, 4. So we're going to have L0. We'll use uppercase here. L0, R0. And that has to be split. So it comes from temp broken up in parts, right? So if you remember, it was something like 4. Oh, and I have a spec. Okay. And then I have this 4, and this is going to be temp 4, 2, right? Like that. So this is just using the same code we had used before. Okay, once we've done that, and we have IV, let's go around. That's the same. IV was just IV to 4. So R1 is just L0, correct? Right? Sure. All right. And then the other one's the tricky one. L1 is going to be L0 XOR key, or IV, I guess. IV XOR R0. We just have to write this appropriately in like the basic commands, but it should be this logic. All right. And there's also the other thing that we have to do is the rounds. So we have to go same number of rounds, I suppose. So now that I have this, I can do the rounds. We just have to think of it in reverse. 1, 2, 3, 4. So 4. Oops. 4. 4 in range, and 3, but this should be a parameter that you're passing, but we can just hard code it for now. So 3 Feistel rounds in reverse. 3 Feistel rounds in reverse. Okay. All right. So we need to do this part. 4. So now is where we implement this logic, right? So R1 is just Oh no, I did assign it to this. I thought I had made a mistake here, but actually I do a, so remember we start with this LR here, and then we produce values that get assigned to LR again. So that in the next one, when we start with this LR here is the previous one. Do you guys see that? So we're passing it one by one. So this is what we need to do correctly here. So needs to be R1 is L0. And then I need the whole this one here. And then what I was saying is these need to become, they go in, they get flipped. They're now going to be the input to the next iteration. You guys see what I'm saying? So I need to make L0 be L1. Yeah. L1 and R0 be R1. Right? Because I'm doing the 3 rounds. Do you guys see this part? This key, right? So because we have to, a block comes in, gets split. Well, these are split once they come in here. R0 and L0. We do the operation, and then that block just becomes the next block to process in the round. So it goes back into the for loop, and the for loop starts with an L0 and an R0. It makes the changes, and we keep doing that until we're done. All right, so this is another part we have to get right in reverse. So now we have this one here. So this should be a couple of encryptions. I think that's in the Feistel round. I had a function over here, Feistel round, and does have 2 encryptions essentially, if you notice. So can we reuse this? That's the key question. I actually think we can. What do you guys think? Do you think we can reuse this function? Because we're just trying to XOR. I'm trying to XOR here these 3 things, right? L0 XOR it with initialization vector, where we're gonna L0 is just a block of byte array. We're gonna XOR it with just 4 elements of IV, and then that result gets XORed with 4 elements of R0. So if we take a look at Feistel round, what does it do? It takes a block of 4, and a block of 8. Encrypt2 is just, it uses encrypt2 twice. And encrypt2 is what? Encrypt2 is just XORing byte array, so that should work. So we take R0 and XOR it, produce F out, and F out gets XORed with L0. And yeah, I think this, we can totally reuse this function. So that makes our life easier, hopefully. So that's Feistel round with those 3 parameters. So I'm going to write it down here. L1 Feistel round, and it just takes the blocks, right? So R1, comma, sorry, takes, I have to do this right. I'm going to put a comment here because, all right. So it takes L0, right? L0, L0, R0, and the IV. Okay, let's take a look at the function. Yeah, L0, R0, and IV, and it'll just return the blocks. Right? You guys see that? So now I have my R1, L1, just flip them, do the 3 rounds, and then once that's done, the 3 rounds of the Feistel network, we're almost done, right? If we've implemented the logic correctly, but it's if we've made a mistake, there's a small one, but we're almost done with the pipeline. So I have now that block goes into the 3 rounds. So what comes out is something similar to what you see over here. So decrypt 2, I believe actually there's a final encrypt. So we still need this final encrypt over here, if you see. But this is on a block of 8, so we need to concatenate these final ones. So that's going to be then 1, 2, 3, 4. And let's call it concat uh, Feistel final block. Very wordy, but just to be clear. And we have to do equal L0 concat R0. Do you guys see what I'm doing? So I just re-put the block together, the final block. And then what happens with this block is that it gets XORed, but this has to produce the plane back. So that's where that trick we had used in the past comes in. We need a new function for this. Right? So we need to do this part here. I believe we're there now. Encrypt to produce that plain text block. So I'm going to do, so I have an IV, and I have, where have we done this before? Did we have this here? Should be the last part. I may not have given you that. So what do? We take the two things, XOR them, and then make them into a char, right? So it should be something we can do. So let's do, I'm going to create a function called encrypt to, similar to this one, but I'm going to call it def. Oops. Yeah. And let's say decrypt to plain letter. Okay. What does this one take? It takes that block. So cipher block. It takes in the IV, I think we're using. Colon. 1, 2, 3, 4. It's going to be these return byte array. Byte array. List comprehension. For I in range. Len of cipher block. just like that. And then here we XOR the final part, IV I with cipher block index. And then this produces something that CHR. I feel like we had done this. Do you guys see what I'm saying? So this is the last part to produce the plain text values. Let me double check this function. CHR. Yeah, hopefully that works. Oh, yeah, go ahead. Why are you returning to the box? Good point. Good point. That's a very good observation. Thanks. Yeah. All right. Let's go back. So I think that's actually all of it at this point. Um, well, all of it for you guys to work on. Um, I feel okay. Yeah. So we've done this part plain. We also have to, we know that we're moving, right? We know, where did we use? I for one. Yeah, so this would be okay, yeah, here. The IV. Okay. I'm sorry, I was getting a bit we have to do this part here, right? The IV to cipher, right, guys? So where do we do that? Encrypt with a key, I think. This this IV needs to change. So initially needs to be something like do you guys see why? So this is the CBC part, right? Where it needs to use the previous block. We're starting at 25, so it needs to use 24, right? If we're on 23, it needs to use 22. And the only situation where we have a problem is where the index is zero. What do we have to use when the index is zero? The actual IV. Do you guys, that's how we're doing it in reverse. So we need to have an if statement for that scenario. So we need to say, and that needs to happen. Yeah, that's fine with the I. So we need to say if I if I equals zero, 1, 2, 3, 4. Then IV equal IV. 1, 2, 3, 4. Else 1, 2, 3, 4. IV needs to be what I did down there. So list cipher index -1. And then now I can just, oh, and this index probably needs to be above then. Index equal len list cipher minus I minus 1. Yeah, because I'm using it down here. Gotta delete it from here. Okay, and then now I can change this back to being the IV. This is actually the CBC part, right? Of this, combining CBC with DES. Okay, so once I have plane, I should be able now. I already did the flipping, and so I should be able to just append. Where do I append? In the for loop here. So list of decrypted list of decrypted blocks dot append. And we're going to call that one. And then we just return that. 1, 2, 3, 4. Return list of encrypted blocks. What do you guys think? Well, I think we've got it. We'll have to check it, but I believe if I haven't missed anything, oops, that's the whole lot. Right. So this should be the entire. Oh, wait a minute. There's this decrypt 2 here. I may have left this incomplete. Decrypt 2, maybe I forgot to return. Okay. There. Yeah. Yeah, we concatenate it. Yeah, so I think that, or for some reason I missed that. Concat Feistel final, right? Okay, so now we get to test it. Let's see what happens. R0 is not defined, so we need to do that. Feistel round. That's in decrypt. R0. Why is R? Oh, okay. Yeah. I put an R. Yeah. All right. So I had an RO in there. Okay. So that one. Okay. So now the next one, something about byte array and int. So this is happening in encrypt 2. Go Feistel round. It's happening. It's happening here. Let me put an input here. Print debug. Input control X there. All right, so far it gets that far. Okay. So it's some issue with the so that's good. So the code is getting at least as far as in this function, as far as here. And if you notice after that, decrypt 2, decrypt 2 comes out to this plane here and just appends. So we're close to the end, even if our logic is a little off. But there's some kind of bit array issue here. So we're in this function, decrypt 2. IV is a byte array. Temp should be a byte array, right? So that I'm surprised that that broke. Decrypt 2. Get this and Feistel around, I'm reusing it, so that might be the issue. Feistel round goes in here. What's the problem? I'm going to move the input after here. Not there either. Well, where's the error then? Okay, so it's not there. But it makes it through the Feistel round. Right? You guys see what I'm doing? So it did make it through that. So then what would be the issue? Then all I'm doing after that is like changing the names. L0R0, this L0R0. That's how we concatenate it up here, right? I didn't do anything special, so we return this, so that actually then it should exit out of that function here, right? It's debug, oh, print, debug, input. All right, let's see. If I'm correct, this is the point. It should not break here either. Oh, it did break there. So where is this happening? Let me put something. Okay. Same mistake I had made before. I had an O instead of a zero. Okay. Let's try that. Cipher block key. It could be in the for loop itself. So let me do this. It's a print end, and I'm going to put in here an input here, and then I'm going to list here. Should be 3 rounds. Print round input. I can't figure out where this error is. If you guys see it, let me know. Round 1, round 2, K. And if you notice, it didn't do the last end either. So why would that be happening? That it does 2 rounds, but not the third one. It does one, it does the other, and then all that followed was this print n, which didn't show. Strange error happening in here, I think. In the print. It says unsupported operand X or byte array and int. Yeah, and you can see it's actually here for that last round. Hmm. Round one, round two, round three. So this definitely here, this is the error, right? So it seems to be because this is the trace starts here, and I printed these two values. So decrypt two, or that encrypt actually. See, I printed these two, temp block, temp cipher block. Strange. This returns a tuple. Oh, that may be it. Okay, so this returns a tuple here because there's a comma separated. So there's two, a thing of two. What did I mean to get here? Feistel round. No, but I actually captured two here. What do I do? Feistel round returns. Okay, this is my fault for reusing that function because although they do the same process, they were meant to be a little bit different. So you look at my error here. In this one, I just did the switch here. Do you guys see that? The R1 L0, I just made it outside. And then I'm just like, okay, let's reuse the Feistel network function because it does the operations. But L0 and R0 go in to it. Do you guys see that? But it only returns L1 here. Whereas Feistel network Feistel round actually does return two things because it returns the thing that I sent. Do you guys see what I did? So I could I mean, either redo the Feistel round function for decrypt to handle the logic, or I can just handle it differently. So, but do you guys get the issue here? So that was my mistake in coding it. Um, so this is your assignment, right? It's almost finished. I wanted to give you something that didn't break, so I'll try to fix this. And then you just have to play with that logic, right? It may be almost there, right? But you have to think through the whole Feistel network back and forth, okay? But let me see if I can um, you have, this is your homework assignment to really kind of think about this, but just from a logic perspective, not from a breaking. So let's see if I can fix this. I just don't want to do this too quickly. So I kind of like using this function. Um, it returns L, right? And we provide R0, right? Is that kind of how it works? So, so technically, L1 is what I cared about. So the solution could be to just that same, as it returns R. Yeah, R0, L0. R0, L0. So it would need to be something like this. R1 or R0. Yeah. Yeah, because it returns 2. And then I assign L1 to L0 and R1. I already have that. So, okay, it made it to the end this time. Okay. Debug. Oh, so now it's doing the whole decryption. Do you guys see that? At least it's getting to the end now, right? So this is the behavior we want. Okay, so that means everything should be happening. And now you can just focus on the logic without having to deal with these little problems. Okay, let's see if we can get to the end. And I'll post this on GitHub so that you guys can get it from there. I'm going to rename this 3. So I'm going to call it Feistel Desk 3, and you guys can work on it. All right. And it should be a fun thing to get it to work. I think we're pretty close. But let me just need to remove all those inputs. Still have a few minutes. Input. Yeah, there's an input here. And I think there was a second. I'm going to remove this second in. Okay. Control X, Y. There must be another one. I mean, if you guys see it, let me know. Oh, here. Okay. All right. So how far do we get? It says, okay, the print. So that's easy enough. After pickle, decrypted. So I need to fix that. That's in the main. So print after pickle decrypted plain and then the join. Okay. Clear. It's in the joins. So I'm just going to comment that out. And as this had nothing to do with the encryption, so we can add it back later. All right. Done. All right, so there you go. So obviously there's something in the logic, right? Because it's not, but it runs from beginning to end. Do you guys see that? So it's almost there. So now you have to go back to the way that the Feistel network works with CBC. The pipeline runs pretty well, but make sure that you are able to decrypt. Obviously, it'll work when something legible shows up, right? All right, and we, ask questions if you haven't, but yeah, so this will be your homework assignment for Thursday. Any questions? Yeah, please. Oh yeah, no, right, a week from today. So you have a week from today, so take this as your just an extension from CBC. If you got CBC right, look at that and then just make sure we got the Feistel network logic correct. The end of the day is just XORing blocks, right? So just make sure the forward and the reverse. I think the forward is correct, but double check it as well. All right, guys. So I'll end the video here. I'm gonna load it right now.